Hello and welcome back to Friday Minis. USB, a technology that we use all the time, right? You can barely find any device these days that don't have USB. Of course, USB is really powerful in the sense that it not only carries data, but it also carries power. That's why we can use USB as a charging cable as well as a data transfer cable. However, here's the interesting thing. Back then when USB first came out, power wasn't really such a big part of the specification. Of course, power was part of the equation in the sense that, well, if you're connecting something passive like a flash drive, you're going to have to power it, right? It's not going to supply its own power. However, there wasn't really that much thought given to higher power devices, right? And definitely not to charging things like phones. This has led to some interesting workarounds to basically allow USB cables to carry more current than the specification actually allows. And today, we'll take a look at few of these methods. But before we begin to understand this, we have to understand what's actually in a USB cable. Your most traditional USB plug essentially carries 4 lines. 2 lines for power, positive and negative, and 2 lines in the middle to carry data. Not too long after, we've got our devices that need more juice, what we've gotten are powered hubs. Essentially, it's a USB hub, right? And you actually connect it to power. So what this means is for all the devices that are connected to the hub, instead of drawing power from your computer, it draws the power, from your separate power source. So your internal connections become quite interesting, right? Normally what you'll have is a direct connection of the 4 lines between your computer and your device. But now, what happens is that the power comes from the external source. What this means is on the side of the computer, the power line is disconnected. Usually, the ground is shared. This is just something that is done in electronics to ensure that there is a common ground between the 2 sides. But yeah, your device is drawing power from your external power source. That's where it's connected to. The 2 data lines remain connected because, of course, your data needs to flow between your device and your computer. So yeah, that was a way for you to, not have your power-hungry devices overload your computer. They can draw from an external source instead. So that was one type of workaround. A second type, which I would say is a bit more controversial, is a charging-only cable. These ones are interesting because essentially they are a cable in which the data lines are just completely missing. Now, in some contexts, this is actually called a fast charging cable, but as it turns out, that effect is, not really reliable and problematic in some cases. You see, the idea is that some chargers will actually short the 2 data pins together. Some phones would basically use that as an indicator to, realize that it's connected to a charger. And some phones would use that as a cue to tell it that, oh, I'm connected to a charger, not a computer, and so I can draw more current. If you have a cable that doesn't have the data lines, it may trick some phones into thinking that it's connected to a charger and thus charge it faster. Now, this is actually not that great because, firstly, you have a cable that doesn't transmit data, but more importantly, you could cause your phone to draw way too much current from a port that doesn't support it. This could cause damage, right? This could cause you to overload your computer. So yeah, not a good idea. Generally, what is supposed to happen is that, your phone or whatever device is supposed to signal to your computer that, hey, I can draw more current if it's available. And your computer can decide whether to give up more current or not. So yeah, the reason for these workarounds is because, perhaps back then, right, the specifications weren't really designed for this sort of purpose, for when devices wanted to charge. Now that this sort of use case has become the norm, with USB-C, we essentially don't have this problem anymore because, USB-C cables are chipped. When we connect up our devices, they can automatically negotiate and figure out how much current they're supposed to put through, right? How much current your device is going to draw. So yeah, finally, these workarounds can be thrown out. We have an official solution. So yeah, that's basically it for this episode. It's interesting to think about how these specifications, when they're being drawn up, the creators have to look so far into the future. They have to anticipate use cases that don't really exist yet. If they miss this, you could end up creating problems later on. and that is an interesting challenge that they have to face. That's all there is for this episode of Friday Minis. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.